backpropagation, this was developed by Jeffrey Hinton. This was in, I think, 1983 or 1984. So with what you're basically doing is, as you have an input to the output, like going from input to the output, you have, every time you put in some new input and output, you, so how you train it. So essentially what happens is you've got an x0 and x1, and after you go through all of the different matrices, let's say the final output is some value, let's say y, like y, y0, y1 is the actual value, and that's, so what you would then do is that when you multiply these inputs, go do the entire operation with all the different weights and cascade it through, thus deep feed forward, you'll end up with a set of, with an output, which is y0, y1. So that output will be very different from the expected output, because this is just some, initially you start off with some random weights in your neural network. You have your input, you go through these random weights, and you determine some output. That output initially will be completely off. It'll have no bearing on the actual real output. So what you do is you take the real output and subtract out the actual output of the neural network, and then you cascade the result back into the neural network and adjust all the weights. And every time you feed new data into it, you will get an output which, based on the new weights of the neural network, and hopefully that's closer, getting closer and closer to the actual output of your, the expected output for your neural network. So as you train it, every time you put an input, you go through the current weights of the neural network, it'll come back with an output of some sort. And then if you take that output, you subtract out what the difference between the expected and the actual, and then use that difference to cascade through that and adjust all the weights. And then once you've adjusted the weights, you take the next input, and it'll generate some expected output. It'll generate an output. You compare that to the expected output, take the difference, go back, adjust all of the weights, and so on and so on. So if you've got 100 data points, input-output pairs, you're going to be inputting 100 inputs, and every time you get an output, you're going to calculate the difference between the expected output and the actual output, and go back and update the weights in the network. So as I feed my data through the system, and I go through like another iteration, and I get the weights are adjusted, and it kind of converges. What will happen is that there's some, so what could happen is that as the weights get adjusted, it comes to, at some point, down to some minimum value. But that doesn't necessarily mean that that minimum value is a global minimum. It just means it is a minimum. So which basically means that trying to actually identify whether or not that's the best answer is very hard, because what will happen is that as you train your model, you end up getting a better and better answer, but you could end up getting stuck in a local minimum, and then that's where you are. But it may not necessarily be the best answer. And in terms of determining whether there's a global minimum to your problem, in other words, does it converge even better? It's almost impossible. There's no way to determine a global minimum for most problems, especially not for this problem. So there are several different types of, there's something called a loss function. And the loss function is basically how you measure the difference between the expected and the actual output. And so one that you'll often see, especially with regression, is mean squared error. That's like MSE or MAE, which is mean absolute error, is oftentimes used in regression problems. Very often when you're looking at classification problems, you'll see cross entropy or binary cross entropy. So binary cross entropy is a case where it has to be one and only one of a bunch of different options. So which means that if you add up all the probabilities, they'll add up to 1. And then categorical cross entropy means that it can be one of a couple, so which means that it can belong to multiple classes, and that you don't necessarily need the values to add up to 1 in those cases. Let's say you have your loss, so essentially your loss function. So suppose you have something like that. Down here, it has a certain value, correct? So it'll be, and that's clearly a minimum. So in calculus, if you remember, when I take, if this is y and this is x, then if that point is a minimum, then you basically can say dy by dx equals 0. And so what you're trying to do effectively, what you want to do is that you want to get, when you do backpropagation, there are different types of optimizers, and the optimizers are in effect how you calculate a derivative. So it's a calculation mechanism for determining a derivative. And when you calculate the derivative, what you're trying to get to is you're trying to get to a 0. So essentially what backpropagation tries to do, you can kind of imagine it takes a value there. It says, okay, well, this isn't 0. So it goes there, this isn't 0, goes there, this isn't 0, and then finally there, that goes to 0. Now the reality is that it may never go to completely 0. But it is basically, using this, the idea is that you are going to explore a local minimum in terms of the distance between the two points. So this basically represents kind of the distance between 2 points. And what you're trying to do is figure out how do you get to the minima. And so the minima will adjust the weights in the system. So in this case, this would be some kind of curve like ax squared plus b equals y. So that would be the equation for something. So ax squared plus b is kind of like, this is probably like a 1 plus c. So that would be the full equation. But let's say you've got ax squared plus bx plus c. And so what that basically does is that gives you a curve of some sort. It'll be a parabolic curve. And what you want to do is then figure out, let's say you don't know the quadratic equation, so you don't know how to solve for that. So what you do is how do you then determine ax squared plus bx plus c? Well, it turns out that you can actually, there's an algorithm, a recursive algorithm, or an algorithm that will kind of take you so that you can determine the a, b's, and c's there. And the way you do that is you take essentially the derivatives with respect to these different values. And ultimately what you want to get to is get to a point where the derivative with respect to that value is equal to 0. And so all backpropagation is figuring out the set of, in this case, these are sort of your weights in your system. So you're trying to figure out the right combination of A, B, and C that gives you the least amount of variance.